Hello class, this is Mr. Lehman, and today we're either going to be doing Intermolecular Forces Lab in class, or you're going to be doing it from home, virtually. So our question that we're starting off with is, the stronger the intermolecular forces are within a liquid, between the molecules in a liquid, the faster or the slower that liquid will evaporate. So we're trying to tie together the intermolecular forces, the strength of those intermolecular forces, and the rate of evaporation of a liquid. And so I'll give you a second to try to answer that. Okay, here's the trend. The stronger the forces of attractions are between the molecules within a liquid, the slower the rate of evaporation. And that's because the molecules are sticking together with greater force. It's going to take more energy to overcome those stronger intermolecular forces. So what we see is that liquids that are made up of molecules that have weaker intermolecular forces, they will evaporate faster. So think of alcohol, right? Hand sanitizer evaporates very quickly. If you wet your hands with water, it takes a lot longer for the water to evaporate versus the alcohol in a hand sanitizer. So whenever a liquid evaporates, it has a cooling effect. So think about that. So hand sanitizer evaporates very quickly. It has ethyl alcohol in it, and it makes your hands feel cooler. Why is that? It's because the molecules, the liquid molecules that are evaporating, are the liquid molecules within that substance that have the greatest amount of energy. Those are the ones that are able to break free from those intermolecular forces and to turn into a gas. So that means that the remaining particles in the liquid all have less energy. So within a substance, some particles have more energy, some particles have less energy. So it's the higher energy particles that are evaporating, and that means that the remaining liquid particles have less energy. And less energy, less heat energy means lower temperatures. So as liquids evaporate, temperature will decrease. The other thing, as we learned about in class, heavier particles, heavier molecules, heavier atoms that have more protons and electrons tend to have stronger intermolecular forces compared to their lighter counterparts. So the more mass, the more protons, the more electrons a substance has, the more positive and negative charges that make up a molecule or make up an atom, the chances are the better it's going to stick together. So heavier particles, stronger forces of attraction, lighter particles, weaker forces of attraction. And that will influence the evaporation rate of a liquid. So here's the data table that you're going to fill out. You have some pre-lab questions that you want to answer based on reading the lab document. Once you're done with those pre-lab questions and you're done labeling the molecules, partial charges, and trying to figure out if each molecule is polar or not, here's the data table that you're going to complete during the lab activity. I put the 5 different materials. We got water, we got methanol, we got ethanol, acetic acid, and hexane. I put the molar mass. The molar mass is essentially how heavy, the mass of the particle. We'll learn more about that later in the year. But we can see water is made up of the lightest particles, 18 grams. Hexane is made up of the heaviest particles, 86 grams. All right, and then you want to look, is hydrogen bonding present? That's important because if hydrogen bonding is present, then the forces of attraction will be stronger. The starting temperature, once you stick your thermometer into the liquid and hook it up with the iPad, or if you're watching my video of me doing it, the starting temperature is the temperature, the highest temperature at which you're starting at. That's the initial temperature, and then once you take that thermometer out with the liquid soaked on the cloth, I'll show you what I mean by that. The temperature is going to drop as the liquid evaporates. And so based on the video or based on your lab experience, you want to record the lowest temperature reached during evaporation. And this is called delta T. Delta T is a change in temperature. That is basically how much the temperature dropped by. So for instance, for water, I'm just making up these numbers. If water goes from 20 Celsius down to 15 Celsius during evaporation, then the temperature dropped by 5. All right, so it's just a difference. Starting temperature, subtract the final temperature. How much the temperature dropped by. All right, so I already mentioned that. Here's the structure of the molecules. So here's water. This is methanol. Here's ethanol. Notice these are both alcohols. One alcohol has 1 carbon. Alcohol have an OH on the end. Here's another alcohol, ethanol, which has 2 carbons. So it's bigger, it's heavier, but it still has an OH on the end of it. Here's hexane. I didn't draw in the hydrogens, but every single place where there's a line here has a single bonded hydrogen. In organic chemistry, we tend to leave off the hydrogens because things get crazy when you get really big molecules. And then here's acetic acid. Now, acetic acid has an OH, just like an alcohol, but it also has another oxygen that's double bonded to the same carbon. All right, so if you're doing this in person today, you want to make sure you try to get at least 2 of the 5 chemicals tested, and then whichever ones you don't test in person, you can watch my videos. And remember, I just pointed all this stuff out, what those variables mean. And then here's the setup here. So we're going to use these Bluetooth temperature sensors to hook up to our iPad. We're going to use the SparkView app on our iPads. And once you sync these through Bluetooth, we're going to take a piece of paper, special paper, filter paper, chromatography paper, and we're going to use a rubber band and secure that to our temperature probe. And we want to secure it as close to the end as possible. Looking at this, I probably should have slid it down just a little bit more, so that way the paper is at the very end. And then we're going to dip it in our substance. This is water, so I would dip it in the water, and then I look at my screen, look at the temperatures, and once the temperature stabilizes, I'm ready to start. I'm going to pull out my temperature sensor, and I'm going to lay it on flat on my lab table, and evaporation will take place. And as the liquid evaporates from the cloth, the special paper, it's going to cause the temperature to drop. And that's what you're going to see in the videos. So that's the lab that we're going to do today, and then I'll give you Tuesday some time to work on that as well. So, all right. So if you have any questions, let me or Mrs. Lego know, but I hope you have a great day and enjoy the lab.